Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistants, and today we're looking at concentration units. So let's get started. 0.928 grams of sodium chloride is dissolved in 46.5 grams of water. What is the percent mass of sodium chloride in the solution? So percent mass is one of the concentration units that you have learned in your lecture dealing with solutions. So, and it's probably one of the simplest one. All it is mass of the solute over mass of the solution. It's important to recognize that we're dealing with the solution and not the solvent. You can see the mass of solution as equaling mass of the solute plus the mass of the solvent. So you have to account for both solute and solvent mass in order to get the mass of the solution. And then you simply multiply it by 100%, and that'll get you your percent mass of solution. So in this case, all we have is we're given the mass of the solute, which is 0.928 grams. And we're given the mass of the solvent and the mass of the solute. So we need to do 0.928 grams plus 46.5 grams. Multiply that by 100%. And that gets us 1.95%. So that is the percent mass of sodium chloride. So that's a relatively easy one. In fact, that's probably the easiest concentration unit that's addressed when dealing with solutions. But none of them are very hard, so don't worry too much about that. If you've gotten this far with the math, the dimensional analysis, these will be a piece of cake. So, next we're asked to calculate the molality of phosphoric acid solution containing 42.4 grams of phosphoric acid in 819 grams of water. Now, molality, which is little m, is equal to the moles of the solute divided by the mass of the solvent, and that has to be in kilograms. It's very important that you recognize that that has to be in kilograms and that it's the mass of the solvent and not the solute. Okay, so we need to find out what the moles of solute are and what the mass of the solvent is. Well, to change the mass of the solvent to kilograms, we can simply cross out that G and put a decimal, 3 over. That's just taking 819 and dividing by 1,000, and we're going to change that to kilograms. So that's going to be our mass of the solvent, is 819 kilograms. As far as the moles of solute are concerned, we're going to just call this N. And the moles of solute, and the solute is the phosphoric acid itself. We're given the mass of it, which is 42.4 grams. So we need to take that, 4 grams, and divide by its molar mass, or multiply by 1 mole over the molar mass of the mass, which is 98 grams. If you take phosphoric acid is H3PO4, so the mass of 3 hydrogens plus the mass of 1 phosphorus plus the mass of 4 oxygens will get you 98 approximately 98 grams. And that'll give us 0.433 moles. And then it's just a matter, if you want to cross out your units, that's fine. And then it's just a matter of plugging in what we have from calculated, our moles and our mass of solvent, into the molality equation. So we're given 0.433 moles divided by 0.819 kilograms, and we are left with 0.529 moles per kilogram, or sometimes it's referred to as molal. And again, we can cross out, well, we don't have to cross out, let's edit. Okay, our next one is we're given the density of 2.54 molar aqueous solution of ethanol is 1.105 grams per milliliter. What is the molality of the solution? So this is a little trickier. What you have to do is think about this in terms of factoring out liters, okay? What is this actually saying? What is molarity actually saying right here? Well, what it's saying is that you have 2.54 moles per every liter of solution. So let's just pretend for a second, for the sake of this problem, that we have 1 liter of solution. Because honestly, once we have that, we can calculate everything else. So, and in those terms, if we were to do that, we need to look at the density in terms of liters. So if this is 1.105 grams per milliliter, it could also be construed as 1,105 grams if we're dealing with 1 liter. That's taking density and multiplying it by volume in order to get mass. Our volume is 1 liter. Our density is 1.105 grams per milliliter. So just changing 1 liter to 1,000 milliliters means that you're multiplying 1.105 by 1,000. So that gives us the mass, and both the mass and the number of moles. So now we just need to take our moles of ethanol, because what we've done here is we've removed the liter component. It's just 2.54 moles, and we have 1,105 grams. So let's find out what 2.54 moles of ethanol actually is. Again, it's just dimensional analysis. You're going to multiply by your molar mass of ethanol, which when you calculate it out is 46.06844. You don't have to go that far out, but grams, which gives us 117 grams. So now we need to figure out what the excess is, because we're given the concentration of ethanol, and we've determined that if we were to deal with a liter of this solvent, of the solution, then we only have 117 grams. However, the density of the solution would suggest that there's actually 1,105 grams. So we have the mass of the solution and the mass of the solute. We can now find the mass of the solvent, because if you recall, mass of solution is equal to the sum of the mass of the solute and the mass of the solvent. So if we were to say 105 grams minus 117 grams, that would give us the mass of the solvent, which is 988 grams, which for our purposes we want in kilograms, so it's actually 0.988 kilograms. So we have the moles of the solute, which are right here. That's our moles of solute. And we have our mass of solvent in kilograms. We can now calculate molality. So little m is going to equal 2.54 moles over 0.988 kilograms, which is equal to 2.57 molal, or moles per kilogram. So that one was a little more difficult. Took a little bit of critical thinking on our part, but it is achievable. So always remember, especially as you're relating concentration units to one another, to try to keep it as simple as possible. I generally look at it in terms of, if you have the molarity, it's just saying that it has a certain number of moles of the solute and it's in a liter. So if you're trying to relate different units together, you can just consider them all in a liter, unless stated otherwise. Finally, we're asked to calculate the molality of a 34.5% by mass aqueous solution of sulfuric acid. Again, we're relating two units together, so this is going to be a slightly complicated, but not very, problem. So we're going to start by saying we need to figure out what percent means, that 34.5% means. And we could do that by saying, well, that means that sulfuric acid, if there were 100 grams of the solution, then sulfuric acid would be 34.5 grams. So, under that presumption, we could say 34.5 grams. If we pretend like we have 100 grams total, 34.5 grams are sulfuric acid. And then we could simply divide by the molar mass, which is just multiplying by 1 mole over 98.079 grams. And that'll give us the moles of the solute, which is 0.352 moles. And then we need to figure out how many kilograms of the solvent we have, because we need to find the molality. So we have the moles of the solute. We now need to get the mass of the solvent. So again, coming back to the idea that we have 100 grams, all told, 34.5 of them were sulfuric acid. So the difference between the mass of the sulfuric acid and the total mass should give us the mass of the solvent, which would be 65.5 grams. And if we were to change that to kilograms, it would be 0.0655 kilograms. Now, we just simply plug it into our molality formula, where the moles of the solute, 0.352 moles over the mass of the solvent in kilograms, 0.0655 kilograms. Once you find you've divided that up, gotten your quotient, you end up having 5.37 molal, or moles per kilogram. So it takes a little bit of problem solving, a little bit of critical thinking when dealing with conversion between concentration units, but it's definitely worth some practice. Take your time, go through a couple more problems that are like this, and try to familiarize yourself with the concept of putting things in terms of a liter or 100 grams in order to achieve your goal.